In this session, we will discuss about electrochemistry. In a nutshell, we will discuss about reactions or chemistry that involves electricity, or basically reactions that would involve transfer of electrons. And such reactions we call the redox reaction, which is reduction and oxidation reaction. When we have reactions that we have discussed in the previous chapter, we always try to balance the reaction by making sure that all of the elements at the product side will have the same number or same amount with the ones at the reactant side. In redox reaction, the way to balance such reactions is not only making sure that they have the same number of each elements, but also the same total charge for the product and for the reactant. Oxidation and reduction can be identified based on this following criteria. Oxidation normally involves reactions that release electron. Reduction will accept the released electron. Oxidation normally also involves increase in oxidation number of a certain element, and reduction involves decrease in oxidation number. The elements that undergoes oxidation, we call them the reducing agent or a reductor, and the one that undergoes the reduction is called the oxidizing agent or oxidator. Now let's take a look at examples of redox reaction and how to balance them. Suppose we have the simple reaction of aluminum solid plus the ion of copper becoming an ion of aluminum, or a cation to be precise, plus a solid of copper. This is a redox reaction because we can see that in this case there is a change of oxidation number for each of the elements. If we take a look at Al first, or aluminum, in the reactant the oxidation number is 0. This is typical for any neutral elements as such. And here the oxidation number is 3 plus, just like the charge. The copper at the reactant side has an oxidation number of 2 plus, while at the product side, the copper has an oxidation number of 0. Therefore, we can say that Al undergoes oxidation, meanwhile Cu undergoes reduction. Furthermore, we say that Al is a reducing agent and Cu2 plus is an oxidizing agent as itself undergoes reduction reaction. Normally, to solve such reactions, we will have to write down two different half reactions. We can write down the oxidation half reactions and reduction half reaction. So for oxidation, we have Al becoming Al3 plus, and for reduction, we have Cu2 plus becoming Cu0 or Cu neutral. Now in this case, we have to balance not only the amount or the number of the elements, but also the charge, as we discussed. Here we have 1Al, here we also have 1Al, so the number is already balanced. However, on the right side we have 3 plus, on the left side we have a neutral element. And in this case we always add only electrons. So we have to add then electrons on the right side. We have to add 3 electrons on the right side because each electron has a negative charge. Therefore now our product side will become neutral, just like our reactant side. And similarly, for the bottom reaction, we have to add 2 electrons at the reactant side, so that our reactant side is now also neutral, just like our product side. And here you can also see that oxidation reaction will release electron, and the released electron will be accepted by reduction reaction. Now in this case, we have to have the same number of the electrons being released with the electrons being accepted. Therefore, in this case, we have to multiply the first reactions by 2 and the second reaction by 3. Therefore, the N number of electrons being transferred is actually 6. Please remember this N variable because later on we will use this a lot. Becoming 2Al3 plus 3Cu. With the N again, or the number of electrons, is equal to 6. Now you can see that we have the same charge on the reactant side, which is plus 6, with the one at the product side, which is also plus 6. This is the balanced reactions that we were looking for. Now sometimes we will see a different reactions where we have to add water molecule. Suppose we have this reaction. We can also immediately see that this reaction is a redox reaction. The easiest way would be seeing the iron. On the left side, the iron is 2 plus. On the right side, the iron is 3 plus. In this case, we have to determine the oxidation number of chrome. Normally, oxygen has -2 as the oxidation number. If we take X as the oxidation number of Cr, we can calculate that 2 multiplied by X plus 7 multiplied by the oxidation number of oxygen, which is -2, will be equal to the total charge, which is -2. So 2X will be equal to plus 6. Cr will change from plus 6 at the reactant side to plus 3 at the product side. Therefore, Cr in this case will undergo reduction, while Fe will undergo oxidation. So now let's try to balance this reaction. As usual, let's write down half reactions. Half reaction of oxidation and half reaction of reduction. The oxidation will be quite easy because in this case we only have Fe becoming other ion of Fe. So of course on the right side we have to add electron. Make sure that you add it on the right side, therefore it is indeed an oxidation process. It gets a bit more complicated for Cr2O7 2- becoming Cr3 plus. First up, we can see that we have a different number of Cr on the left side and on the right side. At the reactant side, we have 2 Cr. At the product side, we have only 1 Cr. Therefore, we have to multiply the product side by 2. And therefore, in this case, for the Cr, it's already balanced. We would have 7 oxygen at the reactant side. To balance this, we will add 7 water molecule at the product side. So now we have 7 oxygen at the product side and 7 oxygen at the left side. However, now we encounter a different problem. We don't have any hydrogen at the left side. Meanwhile, we have 14 hydrogen at the right side. And in this case, we will balance this by adding the suitable amount of H+, which is 14H+. So now we have every elements balanced. We can check from the number of each of the elements at the left side and at the right side. They should be all balanced now. However, now the charge is still not balanced. At the left side, we have -2 plus 14, so we have plus 12. At the right side, we have only plus 6. Therefore, we have to add 6 electrons to the left side. So now the charge is plus 6 for the left side and plus 6 for the right side. Now to sum up these two reactions, we have to, of course, multiply the first reaction by 6, making the electron number here is also 6. So 6 electrons will be transferred from oxidation reaction to reduction reaction. Therefore, we can write down our total reaction plus 7H2O. This is our balanced reaction. The electron will be cancelled out because now we have 6 electrons at the oxidation side and 6 electrons for the reduction side. Now in this case, this is what we call as balancing the reaction in acidic condition or acidic environment. We can also balance such reaction in basic environment, and in this case we just have to neutralize all of the H plus with the same amount of OH minus. So if we add 14 OH minus on the left side, we also add 14 OH minus at the right side. And now we will get such reactions: 6Fe2 plus Cr2O7 2 minus 14H plus 14OH minus will result in 14H2O. We also have 7H2O. And if we cancel this out with this, if we subtract this number using the existing water, then here we have to erase the 14 and change it to 7. And then here, plus 14 OH minus. And this is what we call as balancing the reaction in basic environment. So if you are to balance such redox reaction in basic environment, I would suggest that first you try to balance it in acidic environment first and then add a certain amount of OH minus. Don't forget to cancel out the water. Then you will get a balanced reaction in basic environment.